pretend.
I mean, I hear them all the time. Sometimes it's hard to distinguish what's a whistle, what's a scream. So, but they definitely have this long, drawn out. And then there's a food begging call, which is more like something like that. It's a long, drawn out whistle slash scream, and that's the food begging call.
Of the adult female?
Female, yeah, on the nest. I mean, they very often, if there's not enough food, they just scream and scream and scream until the males bring food. And even some females, they can have a pile of lemons at the nest, it's still screaming. So the poor male. I know. It's there's a distinct difference between the sexes there. A division of labor, which actually I find kind of cool. And you got your job, I got my job. Come together, raise a family, and leave.
So how similar are the female food calls to the juvenile food begging calls?
They're pretty similar. I've never recorded them, but they're pretty similar. One of the ways that we find chicks when they're, after they leave the nest is to go out there and listen. Or sometimes I'll imitate a food begging call and they'll respond. And that's one of the ways we can find them when they're hiding in the tundra.
Okay. Any other calls you can get to come through?
Today's Snowy Owl Day. You can get the CD I did years ago on all the songs of the owls of the U.S. and Canada. I think it's on our website.
You can do that now here for us.
No, that's all right. Snowy Owls. I'll stick with Snowies.
Okay, so let me try some of these other ones. So the recordings I have are actual Snowy Owls, which Denver.
I'll give you a review of them.
Okay, so these are from the Voices of North American Owls CD set, which is no longer available because apparently nobody does CDs anymore except Denver.
Me. Too echoey. No idea. Terrible.
Tell that to the owl.
Yeah, it must have been. What is it, in a studio?
No, this is outside. So that's a female.
A wild one?
Yeah.
Huh, must be the recording device.
Well, or recording device copied to a CD. Well, copied to something, copied to a CD. A CD ripped my phone, playing my phone through the speaker on my Zoom microphone.
Yeah.
Probably why.
Yeah. I didn't hear anything.
You don't hear that?
No.
It was a very high-pitched, supposedly begging call with some little chitters.
Oh, maybe a chick with chitters? If it might have been in the nest?
Yeah, it was in the nest.
Yeah. Yeah, because you can hear the chicks. The sequence is okay, but it's usually a little deeper.
I like how you critique the owl's own calls.
Yeah, well,
what about individual difference?
The ones I do are just, it's not that much. I mean, I've worked on 285 nests, so, it's kind of, there's a base one. But anyway, that was fun.
Okay, so we should have had enough time for most of the folks to get here. So I'll start the intro. So my name, I think many of you know me already. I'm Carla Bloom, Executive Director of the International Owl Center, here with Denver Holt, founder and director of the Owl Research Institute in Charlotte, Montana. So just a little bit of background for those of you who are not familiar with where Houston, Minnesota is, which is the vast majority of the population. We're a town of a little less than 1,000 people in the toe of Minnesota. And the only reason we have an owl center here is because it sort of evolved and happened here. You wouldn't say, hey, let's start an international owl center and plop it in Houston, Minnesota. But that's a whole other story. So when we had to close down our education center during COVID, we thought, well, you know what, we were already doing Zoom programs with schools. Everybody was stuck at home. We all got forced to learn how to use Zoom. So, hey, let's contact some cool OWL people and ask if they would do free presentations. We made them free to everybody, and then just asked those who were able to make donations. And that has made this run the whole time. So we started this in 2020. This is now our third year. We do just a few now during the winter instead of every Sunday afternoon at 1 like we did the first winter. So we're very thankful for the presenters that come here and take their Sunday afternoons, and like Denver skips a football game to do this.
I know, Patriots.
Yeah, so he was going to whine to all of you who are watching about missing the football game, and I said, your whines are going to fall on deaf ears because all of those people chose to watch you instead of the football game. So obviously they're not going to be sympathetic. You can watch that later anyway. So a few things about what we're going to be doing here. The chat in Zoom is going to be disabled, so no chatting there, although we will be posting some links there, like to Denver's website and some other things. YouTube chat, for those of you watching us on YouTube, that will be live. We can't turn that off. Please keep that on topic and keep the chat to a minimum so people are focusing on Denver. At the end of Denver's presentation, we will take questions. Those of you in Zoom can put those in the Q&A section. Those of you in YouTube can put them in chat. Several of our chat room moderators are over there helping out, and Owly Keep is Tristan from the Scottish Owl Center, and he will be transferring questions over to me. And at the end, Joe and I will take turns going through questions and fielding them to Denver. And with this large of an audience, there's a very good chance that even though we'll take questions for about an hour after the presentation, there's a decent chance we won't get through all of them. So we sort of sift through the questions and try and pull out the ones that are the most important ones and kind of give a variety. So we don't just go down the list, just so you know what to expect at the end, because there's just so many questions to be asked. This particular presentation is not going to be saved for later viewing. Some of our other ones, or many of the other ones, have been. If you want to see other saved ones, you can go to either our YouTube channel, the International Owl Center's YouTube channel, and look for the playlist of the Virtual Owl Expert Speaker Series, or you can go to the International Owl Center website under the programs on the Virtual Owl Expert Speaker Series page, and then see links to those down there. And there's many reasons that some are saved and some are not. Denver generally earns revenue from doing presentations, and also he's going to be sharing some unpublished data with us, so it's important that we just don't leave that out there, and are very thankful that he's willing to share that with us right now. I think that's the main stuff. Oh, specifically want to give a shout out to the Carl and Verna Schmidt Foundation. They are partially supporting this series this winter, so yay to them. And thanks to all of you who are watching that made donations to help support this series, because not everybody is able to. So just those of you who are willing to pay and able to pay helps everybody on the planet be able to learn. So right now, as of when I checked this morning, which was quite a while ago, as far as registration go, we had over 600 people registered from 42 or 43 states and at least 13 different countries. So this does enable a lot of people to learn. So Denver also is going to be, if you like seeing him here, and you're going to be coming to the World Owl Conference this fall, he's going to be our keynote speaker at the banquet at the Owl Festival, or Owl Conference. Owl Conference and Festival are very different things for very different audiences. The conference is research designed for researchers. The festival is for, he's spoken at our festival also, designed for general public. But his presentation at the conference is going to be focused on long-eared owls. So different topic, another long-range research study of his. So Denver at the Owl Research Institute focuses on long-term field studies. So you can see he's got enough gray. He's been going for a while, but he's not completely white, so he hasn't been going extremely long. He still hopefully has a lot of years in him to do a little bit more.
It was red last week.
Right. Yeah, you did that to make yourself look older. So anyway, hopefully he's going to keep going for a long time. The Snowy Owl work's been going for 31 years. How long on the long-eared owls?
37 long-eared, 40 with short-eareds, and then 30 plus pygmy, saw-whet, boreal, and then our younger studies are, 5 to 10. And we want a minimum of 10 years for every study, really.
So you still got a ways to go.
I
What
do.
the, yeah, I mean, you've got a, I mean, there's people been doing stuff for 50 years. There's been at least one doing even research for 60 years. So keep
Very
going.
cool.
Yeah. So without further ado, I will turn this over to Denver.
All right. So what do I do now? Hit share screen.
Yep. Do your share screen button.
Let me try that. Stick with me
Then,
in case I screw it up.
yeah,
Hang in there, you guys. Let me go to from beginning.
got it.
Is that it? I think that's it. Is that
Yep.
how's that look, Carl?
Perfect.
So am I ready to start? Okay.
Yes.
All right.
Go for it.
First of all you guys out there, I just want to say thanks to Carla and the Owl Center for having me speak to you guys. We've been trying to get me to speak for a number of years, but I'm always pretty elusive. And so finally, we narrowed something down. And I want to thank you guys for attending. Sounds like a pretty large group out there, especially on Sunday football for the United States and Canada. You know, I'm missing the Patriots. And so what I want to do before we get going here with this is just say, Carl asked a question a moment ago about, the studies, and we've got long-term studies. And I just want to say I realized this early on in my career that if I was even lucky enough, when I went to the University of Montana, I studied history and wildlife. And I was, thinking, gosh, it'd be great to have a wildlife job, but the traditional homes of research, the feds, the state, and the U, if you were lucky enough to get a job. But I also noticed, even though I was in my mid 20s when I went back to school, so not really mature, but at the same time, I could recognize a few things that I'd end up being sitting behind a desk most of my career, going out in the summer for a week here and a week there. And I just always wanted to be a field researcher. So I started the Owl Institute, got made fun of for a long time on that. And now we maintain, some of the longest running studies in the world on several species of owls. But I think the key is that we're field researchers. We do year-round studies. We're out in the field, and the Snowy Owl Project is 4 month season out in the field. So anyway, I'm going to kind of go through here and tell you some of the things that are important to me, trying to balance some data and some cool photographs. I think sometimes we forget the animals we work on and we just make them subject matters of study versus the reasons why we got into it. Why I'm still going to the Arctic for 31 years to study snowy owls, because they're pretty cool. So I want to share data, but just some really neat photographs of why I'm still chasing them around. So anyway, here it is. Here we go. All right, just very a quick summary here. 31 years of breeding study, 30 or 31 years of lemming trapping. Our study area is 100 square miles, or for, the metric people, 214 square kilometers, 285 nests. We've banded over 800 snow owls, mostly chicks, recorded over 43,000 prey from pellets, 3,000 prey from caches at nests. We put the first satellite transmitter on a snow owl ever in the world, maybe the first owl in the world. And we maintain the only really live, 24/7 nesting cams on snowy owls. You can watch them nest. And then I always argue that the snowy owl is the avian icon of Arctic conservation, that is the polar bear. So just a couple highlights there. Here's a study here. Can you see my pointer, Carly, if I do this? I'm going to try to point to it. You see that yellow thing? Okay, so this is Barrow, Alaska, now called Utqiagvik. Utqiagvik's a Inupiat Eskimo name, the original name of this village here. And it means a place to hunt snowy owls. And so as you can see here, there's not a lot of tundra in Alaska, mostly on the coastal plain. Most of it is in Russia and Canada and some in the Scandinavian countries and Greenland, et cetera. So this is where we do our research at Utqiagvik, a place to hunt snowy owls. This is our study site here. Again, it's 100 square miles and 214 square kilometers. This is the Barrow Triangle. Here's Utqiagvik right here. This is traditionally where the Inupiat Eskimo would hunt the snow owl right there. This is Point Barrow up here, the most northerly point in the U.S. This is what the village looks like. Again, this is the Arctic Ocean. This is July. The ice is finally coming off. So it's 71 degrees latitude. And right here, all these buildings that you're seeing is where snowy owls used to nest, which, clearly they don't nest there anymore. So this is the old village of Barrow here. Okay, in Inupiat culture, that's Tommy Coates, the snowy owls. They're kind of unique. So the Inupiats have been in that area 3,000 or 4,000 years. and different villages along the coast. It's primarily a subsistence hunting community. Much of that still is maintained today. Um, Mostly they carve animals that they hunt, kill and eat, etc. A few animals outside of that they carve just because they like. Now, snowy owls, they did eat them, as I say, but it wasn't really a big food source, a subsistence source. Adults were killed, from time to time during the summer breeding season. Eggs were taken to eat, and chicks were taken to be raised as pets. But they just admired the snowy owl outside of a subsistence animal, and they don't carve a lot of other animals that are subsistence. So this is a walrus ivory carving here, and this is bowhead baleen, the black for the eyes, and then this is fossilized walrus ivory for the eyes itself there. That's a crummy picture, but it gets my point across. This is kind of what snowy owls see when they come back. And so, they start moving through the area in late April or so, and by early to mid-May, they're selecting nest sites. And so the tall mounds, which we'll look at later, melt off first, and these are what female snowy owls are going to use as their nest sites. But when you look at this here, you're like, well, how the heck do they make a decision to stay or go? How do they figure out if there's enough lemmings? And they appear to do it very, very quickly. How they assess it, I can't tell you, but they do it very, very quickly. And if they decide to stay, then they'll start occupying these mounds. There's some courtship stuff that goes on, etc. As it melts, it really starts to melt really quickly the end of May, but into early June. And so what we do, part of our our methodology to find the owls is to go out on the tundra and look for them. You can see right here, right at this mound, there's a snowy owl sitting right there. So we glass the tundra, the whole place, 100 square miles is sectioned off. We glass the tundra, and we're looking for vertical positioned adult males. I say adult, predominantly all white. And so we look for that. And then either side of that adult male is when we look for horizontally placed owl on a mound, which would be the female. And interestingly, and some of the data is kind of bore this out, but we always used to say that the males are generally 500 meters any side of the nest. They're usually a lot closer to the nest than you would think. And so if we find a male, scan for, and hopefully we find a female. As the tundra melts off, it's pretty easy, really, for these adult males because they glow. And with the naked eye, you can see them for a kilometer or more out there. And so this is, what we're looking for, adult, bright white male snowy owl. All right, we might get lucky and see some kind of activities, females chasing males for lemmings. This seems to be the whole thing, females, give me some lemmings, give me some lemmings. And so that's what we look for, is to hint to where there might be a nest. Ultimately, this is what we're looking for, is a female on a nest. And again, the horizontal posture, you'd be surprised how difficult a female in a horizontal posture on the nest out in the tundra can be to overlook. Even though the males are easy to find, and with binoculars it's a lot easier, but with your naked eye, which is how it's probably evolved, they can be difficult to find. So we're looking for females, but females are looking for not only us, but they're they're always looking for potential predators, because they nest on the ground. So they have to be vigilant. Sometimes we wonder if they even sleep or not. So just bear with me here. So this is a female, and we wanted to give you her view of the tundra. All right. What does a female see? Do they ever sleep? Which we're trying to figure that out. How are we going to define sleep? How are we going to measure sleep? Because they appear to be constantly vigilant, occasionally just dozing off. And we're trying to work on ways to assess sleep. But anyway, without sticking stuff in their head. So anyway, this is what they see. So they're looking out over the tundra. So we learned very early on that these females are, as I said, quite vigilant, and they're watching. So here's, a hominid, myself out here in the distance approaching a nest, but it could be a fox, it could be a bear, it could be a wolf, could be a wolverine, depending on where you're at. And so the first line of nest defense, this is pretty cool. There's a nest you can see, is for the female to flush off the nest as she sees this potential threat coming in the distance. This female's banded, we had a guy in the nest, and, we banned on the left leg. He told us afterwards, oh, yeah, that female was banded. We never did figure out who she was. But occasionally we see our marked birds, at least we believe our marked birds at the nest. Anyhow, so the first line of nest defense is for the female to flush off the nest. We have much more data now, but this is just to give you an illustration. This was some 96 data. depending on who your authority is, whatever, 260, 70 species of owls recognized in the world. I don't know of any other species of owl that flushes off its nest at 400 meters, 450 yards, however you want to measure it for US people and, the other people who use metric. So this is what they do. They're always monitoring. They barely sleep. They're looking for potential threats, which tend to be mostly mammalian predators. But 400 plus meters from the nest is when they flush. And this year, we have tons of more data to add on to this now, but I just have no time to write. So, all right. So we have this figured out as researchers. So as we come to the nest, then you start to see the division of labor nest defense. It's really pretty cool. So females will come in and they'll give you these threatening postures like you see right here. They may land and look at you and scream at you and just give you a threatening display. Males generally and initially are in the air during nest defense. And what they'll do is they'll come in, they'll circle around, they'll bark at you, or they'll hoot, ooh. Ooh, ooh, or sometimes they'll roll it, ooh, ooh, and they'll bark at you. All right. So we're starting to see differences here. Then females may come in next after they flush. They'll come in and they'll start screaming at you. All right. And I can't do it. It's a scream / whistle. My computer really doesn't give it to you, but it's follow me, look at me, something like that. Okay. And then this is pretty rare. Then you'll have distraction displays with a broken winglet. Usually a female behavior, just like a killdeer would feign it's got an injury to lure you away from this. This is male actually doing it. Really, really rare. Males tend to be more aggressive and don't lure you away like this. For example, this male coming in and charging at you to try to get you away from the nest. But this is the ultimate of nest defense. So we categorize nest defense in several behaviors I've just told you. But this is what I would say is the apex or the ultimate nest defense is the attack. It's predominantly a male behavior. And this is what it looks like. You can see the concentration, the animal coming in at you like this here. And if you're a researcher that has dogs walking down the gravel road, 2 big labs, this male owl flew 500 meters across the tundra to attack these 2 50, 60-pound black labs and drove them underneath their truck to move on. But mostly it's directed towards us as researchers here. And you can see that we're at a nest down here in the right column. There's a chick right in here. And this guy here, Paulo, he's a University of Florida climate researcher, and from Costa Rica. He's a plant guy, so I'll hit him pretty good. And so we get to laugh over that. But this is what it's like trying to go to a nest here. We laugh about it. To the owls, it's serious. They don't know we don't mean them any harm. And the behaviors do not change. They do not get used to you. All right. So this histogram, it's just a frequency histogram. There's a few problems with independence here. But what I want to show you is the division of nest defense behaviors. Both males and females bark, but it's dominated by males. Males hoot, females really do. Females scream, males really do. Both attack, but this is a little problem with the independence here and the frequency. But mostly it's a male behavior with some females attacking, particularly as chicks get a little older. And then females tend to display and males really do. So we started seeing these frequencies of behaviors and we thought, hey, I wonder how that relates. And we kind of got this hunch that the behaviors, we wondered if more aggressive pairs were fledging more young and less aggressive pairs. So again, this is just 2 seasons of data. You can't say much on 2 seasons of data. So we looked at all these behaviors, vocalizations, barking, hooting with males, same thing with females. And we started to piece together. And it tended to look like that the more aggressive pairs fledged more young than the less aggressive pairs. Now we have mountains of more data to add to this, which we will as we go along. But as I said, gosh, we're so busy in the field doing research, who has time to write? So anyhow, all right, now we're going to get into a few other things, and it'll be a little choppy here, but this is a female snowy owl. They dig the hole out on the tundra. They lay the eggs, as you would think, and only they incubate, and only they brood, and only they rip prey apart to feed the chicks in the nest. Okay, now imagine this female out there in the distance. I mean, how would you find her? And then I want to make a comment here. See how white she is? For those of you who say you can identify every male and female snowy owl on their winter grounds, and this is just prior to her coming back from their winter grounds, you know, I think it's a lot harder than I read about. And most of the seasoned trappers that I know would say you can't do it. If you're going to try to do it, I would concentrate on the head. Nonetheless, only females incubate and brood. There's hormonal changes, estrogen and prolactin stimulate the feathers fall out. In all owl species where we know it's a single large brood patch, there's an increase in blood flow, and it gives you this really, really highly vascularized, huge brood patch on the snowy owls, where she can incubate. In our area, the highest clutches, I think, is 10. But where she can cover all the eggs with this huge brood patch. And again, only she incubates and only she broods. All right. So we do things like measure the eggs. We look at hatching. We visit nests every 3 days or so. One of the things that's kind of neat, if you read ornithology texts and stuff like that, they tell you the blunt end of the egg up in here is where the air cell is, and birds will break through the membrane here and breathe air before they hatch out. Our snowy owls, and I haven't looked at all our species, but they hatch out from the side of the egg. So I don't know where they're getting their first breath of air, or anything like that, but all of them hatch out from the side of the egg. So they hatch out in the white protopile down. You can see it here. They're helpless at birth. They weigh 45, 50 grams at birth. But they grow very, very rapidly. In 4 or 5 days, you're starting to see the second down, the mesotile down start to come in. Eyes are sealed shut, egg tooth present, pretty much helpless at this time. They can't thermoregulate at this time. And they're totally dependent on the female for food, protection, and thermoregulation. And as I said here, they grow really, really rapidly. And what we see here is just kind of neat. We do a lot of blind stuff, behavioral observations. And, the whole Cain and Abel thing, the big golden eagle female might beat up on the smaller male and kill it, or the egret chicks beat up on the smaller one, throw them out of the nest. We see none of this in the snowy owls. We see the female apportion prey to all the chicks in the nest. When they get a little bigger, however, we might see a little competition, but never outright beating up of each other that you hear about some species. I think barn owls might be an example of that. But we just don't see that. We see this kind of like, nice environment where everybody gets to be fed. But in times of food shortage, the bigger, strong ones get to the table first, I might add, and they get the food. So by this time here, they're growing super fast. We're still doing our nest visits. We're doing our growth, our measurements. We're taking blood, feathers. We're looking at sex and sex ratios. We're looking at multiple paternities and things like that. So we have a lot going on here. But we continue to monitor them. They leave the nest, as I said, about 3 weeks of age, and then we're out there chasing them around. Now, if you look here, again, this is only 2 seasons worth of data, and I'm not a big 2-season person. I should have been doing this more years. We have about 225 chicks here. But if you look at the growth in both these years, it's quite similar. But the thing to remember here, if you look right around in here, it's this week before they leave the nest. Let's just say between 14, 21 days or so, and plus or minus there. This is where most of their body mass, they're really piling on their body mass just before they leave the nest. Because when they leave the nest, they're on their own. They've got to face all the circumstances. The only thing there is they're dependent on the adults for food and protection. But they have to face bad weather, rain, snow, cold, whatever it is, as they wander around the tundra. Potential threats, would be like Arctic fox. You saw that, those black labs there. The Arctic fox might get a chick or an egg from time to time. For the most part, the owls are pretty hard on them and beat them up pretty good. So I don't think they're much of a threat, but they might get an occasional one. Polar bears, on the other hand, they're not much of a predator, but when they occur in the area, we did a documentary with somebody, I don't know, Geographic, Discovery, who knows? But we did some documentary here a while back, and we had a sow polar bear and 2 cubs come to the nest. Male got up, went over there, landed between the nest and the bears. Female got on the other side. Basically, they just barked at the bears. The bears weren't even interested in the nest. They were moving to the coast. But we've seen them attack caribou, and of course, they attack us when we go to the nest. So there's some threats out there, but not a heck of a lot of them as far for the chicks, because the adults are pretty aggressive. They're constantly harassed. The eggers, every time a snowy owl moves, Jaegers and the owls nest fairly close to each other. This, I think, is a parasitic coming through here. But the Pomerans are lemming specialists as well. They nest fairly close to the snowy owls. And every time a snowy owl moves, the Jaegers are all over them. This is how the owls defend themselves. Kind of a cool photograph. And then they, from time to time, they kill the Jaegers and kill their children. And so that's that. So another thing they're looking at here is, again, just prior to leaving the nest, why leave the nest at 3 weeks of age? Everybody's marked. We know all the individuals from hatching, until they fledge. And so, one of the questions was, well, why leave the nest at 3 weeks of age? Is there, big sibs beating up on little sibs, causing the little sibs to leave the nest? Well, that doesn't happen. The bigs leave first. The oldest ones always go first. Is there food stress in the nest? So we can control for that and look at food. So it's not food. So why is there some stressful stimulus in the nest? Why are they leaving? So a friend of mine, Michael Romero from Tufts, him and I got together, and he's the endocrinologist on this here. And so what we wanted to do was look at the corticosterone levels, the fight or flight response from being on the nest and dispersed from the nest. Long story, there's a lot of data that goes into us, but just to make a long story short here, their basal levels are pretty low, although they can mount a response over 30 minutes and incremental bleeding, stuff like that. So when we look at whether you're on the nest or whether you're off the nest, their basal levels, which we bleed them in 3 minutes, we can get a basal level before it registers. It's the hypothalamus, pituitary, adrenal, the HPA axis. And it just tells us that, when they leave the nest, they're not stressed out. And so they seem to be really cool, calm, and collective. And we just think it's because they nest on the ground, and they are subject, as aggressive as they are and great defenders, they're still subject to predation, particularly mammalian predation, and depending on where they nest. And so they probably leave the nest as fast as they possibly can. Shorter owls leave the nest at about 2 weeks of age. That's about as short a time period as any owl I know. And that's because they nest in the ground. They're not super aggressive. They're not big and powerful. The snowy owls probably have constraints because they're such a large species that they have developmental constraints. So that's probably why they wait in the nest until they're 3 weeks of age, and then they can leave. And a horned owl of similar size is probably in the nest 4 weeks or more before it starts branching too far and all that. So we continue to follow them and monitor their lives. You really like them. 31 years, you really like them. You become fond of them. They don't like you. They don't get used to you. They're not fond of you. But we still chase them around, and we can tell when they're sick and struggling. And we try to figure out what their causes of death are. We don't try to save them as much as it breaks our hearts, because that's not our job. Our job is to monitor their life, who makes it, who doesn't, etc. So we try to figure out what's going on. Some of them die, and those that die, we bring back, and we do the rough necropsies, in barrow, and then we send specific organs down to the histopath to try to figure it out. A couple things happen here. We see most of our mortalities, and sometimes in the nest, to the younger chicks when we get prolonged periods of rain. So we get 3 heavy days of rain. In theory, lemming activity is reduced. They're harder to find. The chicks starve. And then we see big chicks like you see here. And once in a while, we'll find them dead. And usually that's the result of someone killing their parents, and they just up and starve to death. When we look at the gross necropsies, all the fat around the heart has been absorbed. Their stomachs are empty, and then they're more susceptible to hypothermia, pneumonia, etc. So pretty sad when that happens, but, we just got to live with it and move on. So they're out and about now, and this is what they do. It's kind of cool. And again, this is part of it. It's not just about graphs and tables. It's about the life of these animals and how cool it is, and the reasons we all got into this as young boys and girls. And so we follow them around, monitor what's going on. You can see this one is banded on the left leg right there. And we capture them every 3 days if possible. We don't let, let's say 5 chicks make it out from the nest. Maybe you find 3 one day, 1 the next, 5 the next time, and all that stuff. And so we follow them right up until, we can't catch them anymore. Things start to happen in this 30-day, 35-day range here. You start to see where some of them are kind of silvery gray and some of them are kind of sooty gray. Some of them have a lot more markings on their wings, and some have less markings on their wings. And when we look at it like this, of course, the prediction was, and, early ornithologists told us this, and we're just kind of buttressing that, is that this heavily marked one might be a female, this heavily marked one might be a male. So, we try to figure out, okay, how can we quantify this, or can we quantify it? So what we did is we took blood from all these individuals, we made predictions of the blood, and then we looked and we tried to score feathers. So we came up with this composite feather here. This is kind of a cool thing we came up with. So if you look at the markings on this feather, so we call this transverse bars. So if the bars go right across, touch the rachis, which is the feather shaft in the middle here, that's a transverse bar. Then we have these irregular bars, but they go across the feather and they also touch the rachis. Then we have these things called spots. If you think a spot, a circle, sorry, but these things called spots. And so we looked at that, and then we took a drawing here. We talked to some of our people who know more about the modeling effects than we do on this. And a long story short, if you look at secondary number four, this is the female up here, this is the male down here, and secondary number four. So if you go back to the spot, if it touches the rachis on secondary number four, in any way, either transverse or irregular, or it doesn't, these two are females, these are males. And so what we found here, and she put it all together, and if you look at S4, you get 98% of them correct, and then it goes on down from there. When we did it, we sent blind, so we didn't tell the geneticists our predictions. We put them, so you have to believe that we aren't lying. And we got all 140 correct based on handling the birds, looking at it, and the models gave us about a 98% success rate here. So a lot of people are using this. And it's good for its first year. Then after that, all snowy owls turn lighter as they age. Okay? It stops at a certain area for females. Males turn wider and wider and wider is what we believe anyway. So anyway, this is not adult. This is a female after she's been aged, sex, just getting ready to fly. And this is what they look like. Last area where they lose their down is usually on the top of the head here. Some of the other things we've done over the years is measure nest mounds. This is kind of funny here because my Inupiat friends up there, and so they think we're out of our minds, They think why would you measure the nest mounds of the snowy owls and compare it to random mounds? Well, we want to see if they're selecting certain mounds. And they go, use your head. Everyone knows that they nest on the tallest mounds that melt off first during the season. We go, yeah, but this is the way we do it, scientifically. It's like, do people use sidewalks? You don't believe it until you measure it, right? So anyhow, when we do all this, but we find out that's what they do. But this is kind of cool here. So the mounds at the snowy owls, think about, wherever you live, and the streets cracking in the wintertime, water drives down in there, it freezes, it pushes the mounds up, etc. So what we've learned over the years, and everyone in Alaska knows it, is that these mounds that the snowy owls using are from the cryogenic processes, but they tend to be about 10,000 years old. So the tallest, oldest mounds that have evolved is what the snowy owls do. So anyway, we compare the random mounds with the others, and what do we learn? We learned that they nest on the tallest mounds that melt off first, just as the Inupiats told us. So anyway, we don't capture as many adults as we can. We just don't have the man or woman power to do it. And so we capture a few, but this is, old work here. This was the first owl in the world, I think. Certainly the first 6 snowy owls in the world with satellite transmitters. The data is much better now. The transmitters are much better now, and there's a lot going on, and Project Snowstorm's got a lot of stuff. The Norwegians, the Canadians, JF's got a lot of stuff going on. Over in Russia, they've got some going on. So it's better now. But these were the first owls in the world, and this is how this all evolved, is from us working with Mark and Linda down there in Boise on this here. And so, again, the data's better, but I want to show you here, this is how this whole, tracking snowy owls by satellites evolved. It evolved from this project here. And of course, the first questions were, well, geez, they're out to sea. What are they doing? They're along coastlines. They're spending a lot of everything along here. They're out in Polynias. And that led to what are they eating during the winter? Who's staying up there in the winter? And we have better data now on that. But people just assume they're eating eider ducks. with very little data on that. I know there's some, but yeah, it could be eider ducks, it could be seabirds, etc. But this whole thing now that we're seeing with tracking snowy owls and making inferences on their movements on that all stems from the early research we did here. But as I said, the data is better now, and they've got just better stuff. Anyhow, so this is it. This is males hunt. Here's the weaponry they used, and you can just see here. There's no doubt. These feathered feet underneath here are more like hair than they are feathers, but no doubt an adaptation for the environment which they live for thermal regulation. So yeah, typical male coming in like this in our area, bringing lemmings to the female. What they eat in our study area, we have a couple species of weasels, which are tied into the lemmings, but the owls eat the weasels. They eat birds as well. This here, their favorite bird, I will say, is kind of funny. Tends to be the red phalarope. That shows up a little bit more. This is I don't know, maybe a 2-week-old chick here swallowing down a full-grown, looks like maybe a female red phalarope, but a red phalarope nonetheless. This is kind of cool. And some people, I don't know why people think they only eat eiders in the wintertime, but Steller's eiders, king eiders, spectacled eiders, all nest in our area. Pretty rare to see a common eider there, but Roar, if you're listening, Roar's got a picture of a female. She flew down, female snow owl flew down and picked up, I don't know if it was a female or a young one, but picked it right out of the marsh and flew away with it. And Roar's got a picture, and it's in Paul Bob's book on that there. So they're capable of doing that. This was a pretty phenomenal one here. This is a male spectacled eider. This is a big bird. Okay. So the female, Dan was in the nest. We're doing some behavioral and photographic stuff. And she perked up. He said she came off the nest, went over the hill. He couldn't tell what was going on. He saw wings and, he saw something going on, but he couldn't really tell what was going on. Whatever. A few minutes later, she comes flying back, bringing this male spectacled eider back to the nest. Okay, so other things that was kind of interesting here. This is an older chick eating a smaller chick. And so chicks die, all right? And in times of food shortage, various things go on. So the female, sometimes she'll, take the chick and gulp it down herself. Other times she'll feed it to other chicks. Other times they just lay there. And how those decisions are made, I can't tell you, but we see it. And some people are offended by it, but this is life, right? Life's tough up there. And so she's trying to raise some chicks. And so when the other one, dies, and she'll make use of it sometimes. And we've actually seen her tear apart bigger chicks have died and feed it to the smaller chicks. That's on some documentary we did with somebody. And so anyhow, that occurs. But in the Barrow region, it's mostly about lemmings. So the Calder lemming, Dicrostonyx, really handsome little lemming, doesn't have much of population fluctuations there. It's just uncommon and kind of runs a flat line most of the time. There's population fluctuations. Turns white in the wintertime, pretty cool, probably an indication it comes above the snow surface to forage maybe a little bit in the wintertime. And then it's the brown lemming that drives the system here up at Barrow. And we're going to talk a little bit about that now. And this is the genus Lemmus. Stays subnivean, we believe, most of the winter. It doesn't turn white, so maybe it does stay subnivean, but it's just, we don't know that totally yet. We're trying to figure things like that out. So this is just to show you it goes from lemming to pellet to dissections. And this is what we do. This is usually student projects. They're good at that, to work and dissect pellets and tally them up. This is one of those tables that, everyone shows at professional meetings that no one can read and people get frustrated with unless you have binoculars, but I'll simplify it for you. And so this is, the owl pellets we collected from 25 years. I kind of get tired of doing it. We've identified over 43,000 prey. And you can see here from the pellet analysis, 95% of what they eat is lemmings, okay? You get a few things in here, and I think we have about 23 species of prey identified from the pellets, but it's just mostly lemmings. Then we do these diversity indices and stuff like that, and some people find value in them, other people don't find value in them. But basically, they're eating one, maybe two species of prey. And as you'll see here, it's really all about just lemmings. And so here's, caches of nests. So we do pellet analysis and we do caches of nests. And when we look at prey species cached at nests, again, you get this table that no one can see and few people care about trying to work through. Simplified, we look at caches at nests. So 3,334 prey cache at nests. It's brown lemmings. 88% is brown lemmings. Even though the diversity of prey increases to about 32 species, it's still all about lemmings. And you add in collared lemmings, and you're still at 90% of what they eat is lemmings. So they're pretty much lemming dependent. Doesn't matter what the diversity indices say. It increases a little bit because of the higher number of species. But basically, in Barrow, Alaska, they're dependent on brown lemmings to eat. This is what it looks like here in a good lemming year, which we haven't really seen in a while. This is about 55 lemmings piled up at this nest here. And they just eat them. They don't rot. It's so cold out normally. So they just kind of pile up. Females sit there. Males bring them in. Females just pick as they choose. We didn't arrange these. This is just what the female did. All right. But what's really cool about this is that it's free data. The owls are providing free data. We realized it really early on in the study. And so when we look at these lemmings, we can get species composition. We can get body mass, we can get sex ratio, we can tell females, nipples present, swollen, lactating, males if they're scrotal, et cetera. So they're providing us what they're bringing to the nest, which is really, really cool. It was really kind of serendipitous research. So, as I said, we do that, get the body mass, sex, and all that stuff. Cool coat. And then, but this is kind of neat. I hope you can see this little block on my screen. But when we look at the mean of the mean. So of the 18 breeding seasons, so we have 30 years of data at this point in time. And of those 30 years, the owls have bred in 18 years. All right. So we look at, the grand mean here. And the lemon. So it's like 71 grams or so, and there's the ranges. And so we get good range. Our sample size are pretty decent, 2,500 plus. Our confidence intervals are pretty tight. And our samples of males and females are pretty tight here. So what they're bringing to the nest is male or female, averages about 71 grams. Sex ratio is a little favored by that, but not significantly, et cetera. And then we also have in sampling lemmings running snap trap lines. So we run, initially, we run 3 lines now, but we have, they're roughly 500 meters long. They're a circular station separated by about 50 meters. They tend to be on mounds. Most of the time, and they're placed in a random circular pattern within 10 meters of the trap center. So we do this, and we get data on what's out there. This is kind of cool here. We count nests too along our sampling line, and we count individual lemmings that we see when we're running the trap lines, a couple of meters either side of the line. All right, and then now when we look at the snap trap results from the 18 breeding seasons, what we see, this is kind of cool. We see that, the grand mean, remember the other one was about 71. These guys are about 48. Ranges are still quite similar here. Sample size, confidence interval are good. Sample size, not bad, not bad for either one. I would have liked to, to get over 1,000. I like to have big samples, but, about 1,200 males, 900 females. So again, a slight difference in sex ratio with males over females, but body masses are about the same here. So then when we started thinking about this, I think Matt, was looking at this because, hey, this is kind of cool. Look at this. We found that, the brown lemmings cached at nests were 71 grams and the brown lemmings snap trap were, 48 grams. And so that was kind of interesting. So the significant differences between them. Then when we look at the snap trap lemmings over 18 breeding seasons with the snap trap lemmings during the non-breeding season, so 12 non-breeding seasons, we see there's no significant difference between those. Sexes were about equal with males slightly outnumbering females. So these data suggest to us that males are bringing home the biggest lemmings to their breeding females. Whether they're eating the smaller ones or passing them up, we can't tell you. We don't know that. And I think it would be hard to get to, but maybe worth trying. But this was kind of a cool thing here. And, we're in the process of putting that all together. So it's all about lemmings, you guys. And in our area in particular, but if we look at, we've done the feeding ecology stuff all around the world, pretty much it's lemmings, it's voles in some areas. So snowy owls and lemmings track pretty well here. This is our longest trap line called our ARF trap line. Blue is the number of nests, red is the lemmings. And it tracks pretty well for all those years. And this year, the snowy owls, we didn't put it in yet. We only had one nest this year. We had a lot of owls around, so I'm a little confused on that. The lemming, this little trend line came up a little bit. We had a little higher lemming success here. I'm hoping for one more good lemming year, one more good snowy owl year. But what's going on here is for some reason, it looks like the owls are going down. Lemmings, I thought were going down a few years ago. Now they're starting to stabilize a little bit more. Maybe the owls will make a comeback. I don't know. And this is, we added a couple other trap lines in the mid 90s or so. And again, so we have three trap lines separated by, I don't know, 10 or more, kilometers apart. There's hot spots throughout the area, and so the owls find the hot spots. But for the most part, in this 30-mile, 100-square-mile area, 30-mile radius, etc., when they're up, they're up. When they're down with individual hot spots that the owls tend to find. But again, it's not a bad fit. All right, so again, it's all about lemmings, and this is our study area. And I wanna talk about this for a second here. So, some of this analysis is pretty complicated, and we got to get, professionals in here to help us. And so these are our nest sites, and there's, the 100-square-mile study area, the 214 square kilometers. And so when we look at each year of the 18 breeding seasons separately, the data indicates that nest placement is randomly distributed within the study area. When we look at the 18 breeding seasons and 279, 883 nests, whatever it is we have right now, we start to see significant clumping. And you can see it here. There's a clump over here and a clump here, a clump here and a clump here, a clump here. And we start to see a significant clumping of nest sites when we look at the data over here. Is another reason to do long-term studies, you guys, all right? So here's what we're coming up with right now, okay? So over 18 seasons, this is 277 nests. We've got some more data on this now, you guys. But when it's really dense, in 1995 at 54 nests, the nests average about, 1,000 meters apart, which is interesting because I told you our own observations, we always used to say, males are going to be within 500 meters either way of the nest. We always said they probably have about a mile buffer around a nest. And in our really low years, of course, you'd expect nests to be really far apart. And this is what I was talking about. So when we look at this data, and again, we had to get some help with the analysis here, some math guru. But when we look at it, they're distributed randomly annually. But when you look at it over time, that they're clumped, and they tend to be in the areas where the highest densities of lemmings are. And that's it. So this is what it looks like in here. These are the nesting areas, and I tell people males are on territories. Now look at this expansive tundra. So when we go out there, we know exactly where to go. You're going to find a male out here, whether it's a nesting female, I don't know. This is also where we tend to see the highest density of lemmings in these, what we call these high center polygons, these high ridge areas. Another thing we're looking at is population estimates. This is crazy here, but so for a number of years, me and a few other people, we've been trying to put something together on open country species of owls. And I just want to show you this because, I know people who study barn owls that say they don't believe there's a 48% increase in barn owls between 1970 and 2014, whatever the dates are. Snowy owls are believed to decline by 64%. Burrowing owls, 35%. Long-eared owls, 91%. Short owls, 65%. And so we have numbers to go with this. So we've been looking at this, and I'm going to just use the snowy owl as an example here. So the global, in 2004, 290,000 snowy owls are believed to be there. In 2006, 72,500 adults. You can see it. In 2009, 14,000 females. If there's a 50-50 sex ratio, which there tends to look like that from our analysis of chicks in the nest, taking blood, but using mitochondrial DNA. 7, 8,000 pairs, 200,000 in the world now, 100,000. Then in 2016, less than 30,000. Then it's unsure if they're talking about pairs or individuals in North America, 15,000 or 30,000, who knows? How can any of these numbers be right? How can we do this without going out and devising surveys? I know people want to know these numbers, but I think the first thing we need to do is do surveys. And there's been a number of us working how to standardize owl surveys across North America. We had a pretty big manuscript doing that. And we're trying to figure out how to do snowy owls. Are we going to do fixed wing aircraft? Can we do drones? Can we do microsatellites? The state of Alaska used fixed wing aircraft to survey the North Slope for ducks every year. They come up, they tell us what the snowy owl numbers are, and they can see them. And I think that's pretty good. Whether you can do it throughout the Canadian islands, the vast Russian Arctic, I don't know. But I think that we need to devise surveys before we come up with another number that is really kind of guessing. And then my friend here, Fred Alan Dorff, who wrote this book, Conservation Genomics and all that stuff, I have him read some of these papers that come out on these population estimates, especially using genetics. He doesn't think they're very robust at all. So kind of goes back to we need to devise some surveys for doing that. How do the snowy owls do in relation to gas and oil exploration? All right. So here you go. This is a gas pumping station out here, a few hundred meters from the snowy owl nest. They do fine, with this stuff here, because these areas tend to be closed off to the public, tend to be closed off. Sometimes, Nubians hunt out there, but hunt caribou, but they tend to be closed off. So as long as you're not riding over them with an ATV or a snowmobile, the owls do pretty good. And they may even do better because these structures here maintain a lot of snow. And when they maintain all this snow artificially, the lemons have a place to hide and stay under, and they're protected from predation. So the numbers, I think, tend to be a little bit higher there. This, however, they just can't do it, right? So Utqiagvik, a place to hunt snowy owls. Yeah, maybe in the past, but, in the 3 decades that I've been working there, we tend to see this shooting and just birds left on the tundra like this. Don't know who's doing it, but we have brought it to the attention. I did go on the radio and talk about it. And I didn't have very many allies, I can tell you that. But the Inupiat people came to my rescue and said, we don't eat ukpik, which is the snowy owl, anymore. People come from all over the world to see them here in Barrow. It's the only place in the United States where they breed with regularity. So they passed a resolution where they don't shoot snowy owls anymore. No one does. And I'm not blaming the Inupiats, but no one shoots them anymore in Barrow, supposedly. This was going on over in Russia. This was kind of gruesome. Some years back, where they were catching them in traps and supposedly hundreds and hundreds of them, and then taking their eyes and sell them in the aphrodisiac market in some of the Asian countries. Anyway, that was bad. We haven't heard much about it since, but supposedly hundreds were taken. Never could confirm any of it. This one was pretty tough for me personally. This is Barrow, and this is Fish and Wildlife Services program. So when the Stellar's Eider was listed as threatened, how are we going to protect them? It's kind of argumentative on if they're really should have been listed and their populations were really declining. But the first thing to do was to blame the Arctic foxes. And so there was a program to kill or trap Arctic foxes. Yeah, kill them. And so lots of things got caught, including snowy owls. When I found out about it and saw this first one, that was that. And so we think we've resolved this issue now for years. And so it doesn't happen anymore as far as we know. And then, some of the other things we've been working on here, why are snowy owls white? Of course, you look at polar bears, snowy owls. You can look at rabbits that turn white or don't turn white, weasels that turn white or don't turn white, ptarmigan, beluga whales, etc. Probably they've evolved a color white to be, match the habitat in which they spend most of the time, which is snow-covered Arctic landscape. But why, of all the owl species in the world, and you can tell some subtle differences between some of the species, but nothing is as distinct as a snowy owl. And so, what we think, we just had a paper on it where we, kind of address these hypotheses and questions and all that stuff. And so why is it that males are the color they are and females are the color they are. And so we think that, I'm going to get to it in a second here, that females, maybe some ancestral trait if they evolve from, a great horned owl type or prototype or a Eurasian owl prototype. Is it some neutral leftover ancestral trait to be marked like this? And does it help in camouflage? If we look at other species of open country species owls, whether it's the barn owl, short-eared owl, burrowing owl, long-eared owl, females tend to be a little more heavily marked overall than males, and males tend to be lighter. So we notice things like only these white males breed, bright white males. Younger males that resemble females do not breed or maintain territories in our area. And then, how long it takes for these males to become bright white, I don't think we really know that. Roar has the best idea of anybody, I think, on it. But perhaps, 4 years or more to become bright white. So the questions, that we were asking, this is what it looks like, This is a male. Why be this bright white? I mean, look, it's almost like a fluorescent bright white. And then why be so distinct in the females like this? Another view of it from the side and underneath. This is what they look like. And only these males breed. Young males that resemble females do not breed in our study area, which tells us that, one, they're older, two, that they have resources. And younger males either by themselves, but very often we'll see them in little bachelor groups, 4, 5, 6, or 7. Sometimes there'll be a female in there, but mostly it's just males hanging out. So the courtship behavior in snowy owls, and I've only seen the tail end of it. We're starting to go up there now earlier in the season to figure this out, where the males get up and they do a display. His wings are down a little bit, a lemon in his mouth. He'll turn, present it to a female, try to entice her. So the courtship behavior, the bright white may act as a social signal. We've just addressed this in a paper just recently here. So that's what we think is going on. And we've often thought, well, do they reflect in the UV range? So we've measured a lot of feathers over the years, and they didn't give us that indication they reflect in the UV range. Again, you got to bring specialists in to help you. So we brought some people from University of Texas, El Paso, who are climate researchers that study reflectance values in plants, and another guy from NASA, and came in and helped us out. So we found a dead male. This is interesting. 7 eggs, female on the nest, beautiful adult male, probably in a good territory. 7 eggs is a good number. It's just like he had a heart attack, and there he was dead. So we took him in. So this is just based on N=1. And anyway, it's highly reflective in certain areas, in particular the shoulders, the chest, upper chest, back, etc. But they did not reflect in the UV range as far as we could tell. But they're 80% as bright as white. You know how bright white snow is. So this is what, they helped us interpret that data. And so very, very bright white, not reflecting in the UV range as far as we could tell. And so even though there's more study needed, there is some, there was one study that says they do reflect the UV range. Other studies say they don't. We kind of fall into the group that says that they don't do it. And then as far as I know, is owls' vision, owls are not able to detect UV light is based on one study here. So kind of interesting stuff there. Then, it needs more work. Autumn comes, you guys, okay? The cotton grass is changing, the color is changing. It's August, moving into September, etc. The owls, the females are starting to, not be as close to the chicks as they used to. They're starting to venture out a little bit more, being on their own. Males are continuing to feed chicks as they're learning how to hunt and all that stuff. And then what happens? Depending on the year, these owls migrate south, and they show up in the northern tier of the United States. And we call this an eruption, all right? An eruption migration. Kind of cool, probably the biggest wildlife viewing event in the nation every time it occurs. People go from all over the place. You've heard of the one in California right now, in Southern California. Thousands and thousands of people have showed up to see it. I'm going down there next week. They asked me to come down and give a talk on it. So the question is, what's an eruption? We have this word. You don't have to read all this. I'll just summarize it. So first you got to go to a dictionary. What is eruption? Well, a sudden or violent, invasion, an eruption of a volcano, etc. Then you go to an ecological definition, which is kind of dubious. People say, well, there's a lot of them. Oh, it's huge. It's a mega eruption. It's a mini eruption. There's really no definition of an eruption, uh, and really no satisfactory answer as to why they occur. Um, so anyway, I think we have to get to that. Nonetheless, a lot of them show up, and when they show up, they tend to be young of the year. And I think you want to talk to the trappers and banders on this who have been doing it for a long, long time. When it occurs, given that so many of them are young of the year, um, I don't think there's any doubt now that it's the product of a good breeding year. And so we suggested this, like 2007, maybe up to 5 young per nest can fledge in a good year. And does that, transfer into an eruption year? Probably does. But we weren't the first people to do it. I know people want to say, oh, we got to figure it out. If you go back to the 30s and 40s, the ornithologists of their time and Gross and all that, they suggested both that, they're starving, and the alternate was, hey, maybe they had a good breeding year, and that tends to be what it is. But a satisfactory definition is lacking, and I don't know if we can get to it. Other than there's a whole bunch of them. Do we say it's got to be 100 or it's got to be 20? They all have to be young of the year, etc. Is it male, females? I don't buy any of the other theories. We have a paper now getting ready here. We asked 16 questions on this. And mostly I talk to the people who actually go out there and band and trap these owls, Norman Smith, David Evans, Dan Z, Martin Stoffel, Mike Blum, Hardy, Tom McDonald. These are the guys who go capture all the owls and put the transmitters on them and band and all that. And so we've come together and we've got like 16 questions that we're trying to address in trying to get to this. The only thing we maybe know right now is a product of a good breeding season. All right, so this is what it looks like. So would you call these both females? Would you call this a female, not a male if you start? What would you call all these? I'm not so sure that we can identify every single one of them in age and to sex on their wintering grounds. Although, some people say they can, but when I talk to the banders and trappers who's, 15 to 45 years experience, they say it can't be done. All right, so let me give you some parting shots here, you guys. Just snowy owls. This is why I keep going up. It's not because we got a ton of data and we can tell you all this stuff about them, but this is why we got into this as young boys and girls, and now as adults, why we still do it. And it's because of photos like this. So I'm going to show you some photos. When the very last one I show you, I'm not going to say a word about it. And it's the only, we put the only live cams on snowy owls in the world, I think, right now. We've done it 4 times. And this one was from last year up in Barrow. But this is just look at these things and just kind of let it sink in. Okay, thanks you guys. Appreciate it. Hope it was worthwhile to you. I'm not sure how to go about questions, but anyway, go to the Institute, support our work. Sounds like a bunch of you out there. We could use the support for all our projects. And Carla, what should I do now?
You can stop your screen sharing, then we can all see you better.
Okay, so stop share. Okay, all right.
Perfect. And then Joe and I will start delving into questions with you. So thank you very much for doing this. And I mean, there's no way you can condense 31 years of everything you've done on snowy owls into one presentation. So you did a great job hitting like highlights of 5 zillion different topics.
There's so much more data. Every one of those tables, or whatever I showed you, we have you got to pile more and more years of data on that. It's just getting to it. Excuse me, it's so hard. Don't forget to go to the Institute, you guys. Okay, I'll try my hardest here. All right, tell me what to do.
If Joe, if we could get it put in the Zoom chat here, the Owl Institute's email address, you can just click on the link also, and into YouTube, that would be great. And definitely do go there and support and donate. The Owl Research Institute is a nonprofit organization, and they run, is it entirely on donations? Do you get some government grants, or is it all donations?
We try to stay away from government grants. Sorry, you guys. But we do try to stay away. Every once in a while, someone will come in and say, "We come do a survey for us, in a national park or a forest and tribal reservations, things like that." But for the most part, we're driven by individual donations and foundations and things like that. So we have a big match out there right now. We have $100,000 grant that we're trying to match, and so always use the help.
Definitely worthwhile to give. Joe, are you ready to start?
Yep, our first question came immediately after we started the webinar, and that is, why are snowy owls attracted to airports?
Well, why are snowy owls attracted? All right, so you're going to say the question, so I don't have to repeat it. Is that correct? Okay, cool. All right, just make sure everyone hears it. You got to ask Norman Smith that. Everyone just presumes because I don't know, maybe tundra-ish. There's really a manicured system in there as far as vegetation is concerned. It's, I won't say isolated, but they're kind of private in a sense, other than the jets and all that stuff. But and then oftentimes, these areas are refuges for wildlife too. So they may just find good food resources there. Many of them tend to be along coastal areas, but not all. So Norm Smith would probably have the best idea of that. He does most of the airport trapping of anyone I know.
Okay, this one you knew you were going to get for sure. The Arctic has seen greater temperature increases due to climate change compared to lower latitudes. How has the climate change affected the snowy owl?
Yeah, we're working on that right now. And we did a little analysis a few years back looking at spring rainfall and didn't find any relationship between that and lemmings and snowy owls. But we have to look at it more closely. In Barrow, they've had a National Weather Service there since the 1920s or so. Whatever's affecting lemmings, so is climate affecting lemmings? There's some data to indicate that from some of the lemming studies around the world. It's going to affect the snowy owl. So that's what we're trying. That's next. But again, we need to hire a climate person and a high-powered statistician, not a student, a high-powered, experienced statistician, and that's why we need to look at that, because we have our lemming data is pretty good. I mean, the snowy owl data is great, but our lemming data is one of the longest, snap trap lemming studies, I think, certainly in North America, but maybe in the world. I mean, we have a lot of really interesting data, and it's beyond our statistical skills. I'm an okay statistician, but not at that level. And that's what we need to do. So we're waiting for that big grant to do that. And whatever's affecting lemmings is going to affect snowy owls. But we had a curve this year. We had 50 males on territory, which told me lemmings are high, but we only had one nest, which told me lemmings maybe weren't high. So something going on. I'm not a believer in the build up over 4 years. I'm not a believer in cycles, period. I think each year is independent of the other year. But it just threw a curve at me this year, so I don't know what's going on. But we need to look at. If anyone out there is a high-powered, statistician that's got a grant, come on over, and a climate person.
Someone would like to know if you can make a comment on the snowy owl located in a residential neighborhood in Orange County, California. The birding community is split regarding the large crowds and the welfare of the attention on this bird.
Yeah, I've been in touch with California Game and Fish or Fish and Wildlife Department, among others down there. They call me. They're gonna bring me down there on the 19th. I'm going to speak on the 19th down there to talk about the issue. I've seen some of the comments. It's funny how, comments can get a little ornery, and, it's hard to say. The bird's been there a month, and it's apparently, it's been there a month. Doesn't seem to be starving. They're trying to go out there and try to find some pellets and see what it's eating. It sounds like that it goes over to a military base where, maybe there's abundant wildlife over there because it's, off limits. How to get there? Who knows how it got there? Did it come from Russia and just come down the coastline? Did it come from Alaska this year, or maybe the northwestern Canadian islands? And just, it's kind of an extra liminal record. It wouldn't surprise me to see them, Seattle across the northern tier of the United States to Boston. But we've had them show up, in Northern California before, pretty rare. Texas, Florida, did it board a ship? Someone suggested that. We do know that they board ships, and that's maybe how the one got to Hawaii several years ago. So hard to say, if it goes out there and then you see it starving to death. I know we all want to help, and you see it and it's weak and all that stuff. Yeah, sure, let's help it, right? But if it seems to be okay right now and it seems to be foraging okay, then leave it alone and see what it does. Is my feeling. And so, but everyone's got an opinion.
So tied to that one, where and when are you going to be speaking in Southern California, and is that open to the general public?
Yeah, I don't know if they posted it yet. I was in communication yesterday. I'm going to fly in on the 18th, speak on the 19th in a hall in Cypress, California, near Huntington Beach. And right now they told me they're expecting several hundred people and then a lot of people online. So you might want to check. They were just getting ready to post it maybe yesterday about California Fish and Wildlife. And then I believe there's 9 Southern California Audubon societies involved in this whole thing. And then, hopefully I'm going to go out there and get to see the bird. So yeah, please join in on that.
There were a few photos of female snowy owl, and someone wants to know, they say it looks like she's molting her flight feathers while incubating. Is that typical?
Yeah, cool question, actually. Good observation, too. Yeah, we have, again, when you're in the field so long and you do so much research and you read textbooks and papers, you say, well, we don't see that. And that's, again, why I defer to those 7 winter trappers, because they know snow owls better than anybody else. Yes, it's very typical. And you might even say that the creation of the brood patch is kind of like the onset of molt, okay, even though it's got functional significance as incubating eggs. But females molt while they're on the nest. And supposedly that's an energetic demand. Well, I mean, how do we know? Why would they evolve it if it's that energetically costly, And we presume that they can't do that, but they molt heavily on the nest. Matter of fact, we've had 3 females who have gone flightless on the nest, and they usually in very, very heavy molt. I was trying to get together with Roar if you could figure out the molt sequence, how old these females might have been. They might have been in their 2nd calendar year, but they were flightless for 2 to 3 days. And they walked off the nest. So the typical behavior, as I told you earlier, is to flush from the nest when danger is approaching. These females walked off the nest each time. 2 of those nest fails and 1 fledged 5 young. We have a lot of really cool stuff that's either new information or contrary to what you would typically believe.
Ruar has raised his hand, but Ruar, I'm wondering if you've got a comment. Do you want to type that into the Q&A and we can pull it out from there?
I can't hear you, Carla, if you need to know that.
Yeah, so it'll probably take him a second to do something. But in the meantime,
no
David Johnson is asking, do the young that leave the nest direct their movements towards the direction where the males are hunting in order to short hop the male in delivering prey? So do they follow daddy around, kind of?
Yeah, we tried to figure out, is there some directional movement going on here? And we really can't figure that out. But what we can tell you is that they tend to be near the female. Okay, she's always somewhere in the neighborhood while the male's off hunting. And what we see when we watch prey deliveries is that, they definitely are moving in certain directions. They're here one day and another day they're 500 meters the other way. But what we see is the male bring the food to the chicks. It's like we can't find them, but if you sit and you do observations and you watch a male hunt, he knows where every one of those chicks are. and he flies in and he drops prey off to them. Now, most of the time, the chicks are in the general vicinity of each other. But sometimes you walk over there and two of them will be huddled together, three of them will be huddled together, or five of them will be 20 yards apart or something like that. And then when he flies in, it's usually, it's kind of like the first one. If there's two together, the first one that gets to him gets to gulp it down. So I don't know if they're following him around. I don't know if there's vocalizations that maybe help, or some kind of visual cue. But the birds, they just move all around, but they stay within the territory most of the time. They definitely stay what we would call the territory. And then they move to ridges. Eventually, when they get a little bigger, they seem to move to ridges. And when they get up on these ridges, these high points, just before they're fledging, that's where they're catching the wind, they're pumping their wings, they're jumping up in the air, and they're developing the pecs, the supracoracoides, and the pectoralis muscles, I think, and all that. But they seem to move up where they can gain a little bit of lift, as they start to push that, 40 days or so. Hope that helps. Maybe I don't know the answer, Dave.
It does look like Rar has said something. He says, good photos of outstretched wings, and I can judge the age of these females.
Good. Write me a letter and tell me. I want to know what the age of the ones that went flightless. I think I sent you a photo, or maybe I talked about it. But the heaviest molt is what I want to know, at what age those females were. Thank you, Ro.
And then, do snowy owl chicks hatch sequentially?
Sequentially meaning the order in which they were laid. Yeah, just, almost exclusively. It seems like we've had a record or two where, they were a day apart, and one of them might have hatched a day before the other that was out of sequence. But for the most part, it's sequentially, and it tends to be about a day apart. Once they fracture the egg, then they break through and make the pip hole. It's usually within that day that they hatch out of the nest. They're usually wet, covered in the white prototile down, and then they dry off to a fluffy little white thing. Kind of a nice looking little thing. I don't use the word cute, but kind of cool looking.
Cute is a valid word too. I know, totally your style. Okay, so here's on the different end of things. Oh, where did this one go? A snowy owl oversummered near Madison, Wisconsin in 2022. How unusual is that?
I think it's unusual, number one, but there are records of it. I think there was one in Oregon a few years ago. Norman Smith had some records in Massachusetts, and there's probably a few more records around. Why that occurs, I don't know. I'm not sure the ages on that, whether they were first-year birds or not, or second-year birds. I imagine maybe they're first-year birds. They just, didn't figure it out, or who knows? Maybe they were comfortable there. I don't know the answer, but it does occur, particularly, I think, in eruption years. But I don't know if this, I don't know of any really big eruption year this year, and yet we got this one in Northern California, which looks like a female. To me, I've only seen a couple pictures of it. It looks like it might be a young female. But there's other people. Again, the winter trappers are the ones you want to talk to. How many they see that stay well into the summer or over winter. So anyway, that they know better than me.
How successful is the percentage of males capturing the lemmings? And could it be that the male is white to fool their prey as a pile of snow and make it easier to capture them?
Yeah, we've done some of that in years past, looking at foraging success and, trying to divide the clock into, I think we had, 3 or 4 hour stints, 3 hour stints, and trying to look at that. We have some data on that, but it really needs to be done and get larger samples and all that stuff. Some people say that when lemmings are abundant, they're just easy to capture. And, when we're out there just randomly walking around watching and you see a male take off, I mean, they do catch a lot of them and stuff like that. What was the second part of that question?
Could it be possible that the male is white to fool their prey, thinking into a pile of snow?
Yeah, I suppose you could think that. I don't believe it, but I suppose, you could think that. Are they white when they're up in the air with a clouded background so the prey can't see them? Kind of like that, counter current camouflage and all that marine mammals may have, sharks may have, and all that stuff. I don't know the answer to that, but I mean, they're on the ground most of the time hunting from a perch. So lemming's eyes are placed maybe like on the top of the head there. So whether they can see out laterally or not, I don't know. I don't know the answer, but I don't think so.
Okay, so a couple from Ruar. So for those of you who aren't familiar, Ruar Solheim actually did our very first virtual owl expert speaker presentation back in November of 2022. And he has done two for us, one on snowies, one on great greys. And you can find his in our YouTube series. He's from Norway. He's done a lot of snowy owl research also. So that's why he's getting referred to here. And he's watching. So he said in late autumn 2014, at least 9 snowies hitchhiked with a cargo ship from east of Newfoundland to Central Europe, and snowy owls were seen in Holland, France, and Spain. But he's also wondering, have you tried measuring the distance from which hunting males discover lemmings from and their strike distance or length?
Okay, 2 questions. Yeah, I'm aware of those birds. That's kind of cool. That were on the ship, and we also get them on ships in the Arctic too. Usually it's kind of an October thing where just groups of young birds will show up. Can't tell you if they're family groups or related or anything like that. They land on Loran towers. People contact us all the time about things like that occurring. We've done some of the foraging stuff, and I can't remember the distances, but a male sitting on like a dead snowmobile out in the middle of the tundra, sitting on the handle foraging. We've measured a couple 100 meters that they've gone out where they perked up. Usually they'll stick their head up, they'll get excited about something, stick their head up, and then they'll go. And we've measured it in the past here, a couple 100 meters, if I recall, and go out there and catch a lemming. We could definitely do more of that and get better samples and all that. But we have looked at that. That was part of that whole foraging thing. What is the distance? I think Norman Smith's got some information where he's seen the birds. I want to say it was a bird that he was talking about. Logan Airport in Boston with all the train commotion and all that stuff. Turn, look at something fly, whatever, a mile away and capture some starling or a pigeon or something.
How much collaboration is there with your institute and other similar organizations around the world?
How much fun? I'm probably at fault on this. I think everybody's pissed off at me all the time. We just do our thing, I mean, some people contact us and I try, but I don't know. We just kind of, we just do our thing. I try to collaborate a little bit, but I mean, I don't have time sometimes, and maybe I should be better at it. So I would say the onus is on me on that. And we have, without offending anybody, probably, one of the most detailed studies on breeding snowy owls in the world, and one of the best data sets on, snap trap lemmings in the world as well. But it seems like everybody wants your data so they can write a paper. So I'm always a little skeptical sometimes, give us your data so we can write a paper. And so that's why I'm a little shy on that, which is why I didn't let Carla keep this thing too. So anyway, I apologize if you're out there and I've offended you. I'll try better to be more collaborative.
Okay, so here's a fun and I think quite controversial one. In many research papers, snowy owls are described as being diurnal. What is your feeling on this?
I guess it maybe just depends on season, time of year, et cetera. If you look at like the breeding season, which I'm most familiar with, if you got a lot of mouths to feed, then you got to go out there and hunt. So what we'll see is during the incubation stage, you go to a nest, there might not be any lemmings. And then all of a sudden there's 1 lemming or 2 lemmings. And the first chick hatches. Then the second chick hatches. Then the third chick hatches. Then another lemming, then piles of lemming show up. So the males are hunting quite a bit during the daylight. You talk to some of the guys who work on them in the wintertime, they'll say they can sit there all day long. And then once dusk comes and darkness, they get very active. So it probably just depends on a lot of things. Hunger, breeding season, time of the year, time of the day. There was some analysis on a cage bird or two, if I recall, and I think it was a female, and she tended to get more active in captivity in the lower light levels as it got dusk. But if you got chicks to feed and you've got 5 chicks in a nest, which is a fair amount, you got to probably do whatever you want. And it goes back to I wonder if they even sleep, sometimes. And so it probably just varies, on circumstances. I think Norman's put some night vision stuff and have some pretty cool stuff with night vision scopes, how active they are at night. But, and I've watched them every once in a while, we'll get in what we call an eruption migration here in Montana, and you go out and watch them, and they don't do anything all damn day. And then all of a sudden, half hour before dark or dusk or whatever, 20, 30 birds rise up and they go out to the fields to hunt. Hope that helps.
Do you plan to do any additional satellite tracking of snowy owls?
Yeah. Hey, JF, if that's you. I should. I was a little skeptical of it when we did it early on. And the only reason was because we're such field-oriented people that I just didn't like the idea of making the inferences, number one. And number two, I just was always concerned about just attaching more stuff to them, and all that. But I think it would be a good thing to do in Barrow. I'm a little concerned about putting them on the Young of the Year now. And I guess, JF would be the best person to talk to on this, I think. But I believe that, most of the chicks they put transmitters on are dead. And so I'm not too crazy about that right now. I would like to do it, but if we did it, right, we got to do it long term, cost money. And then what I would like to see, and I was trying to get the Max Planck Institute behind it because there's so much money, and only they had that money, I think. And Bart finally thought it was too much money for him, is get them outfitted, get as many birds as we can outfit. Let's say 10 birds in Barrow, let's just say there. And then the next year, they disperse. Let's say a couple of them show up in Banks or Victoria in Canada or something like that. Then, they're the only ones you know about. Then you have to go there, okay, and see what's going on, all right? And is there one bird there? Are there 50 nests there? What's the lemming situation there? And I know JF did a little bit of this early on, but we have to do it at a higher level. And then at the same time, we have to go back to Barrow to see if there's no birds there and the lemming populations have decreased. Then let's say the next year you put birds on them, and the next year some birds show up in Wrangel Island, Russia. All right, you got to somehow get to Wrangel Island, Russia. Is there one bird nesting, or is there 50 birds nesting? All right, then you got to go back to Victoria Island or Banks Island. Did the birds all vacate there? What's the lemming situation? You got to go back to Barrow and see that. That's the only way we're going to get this figured out, and it's going to take quite an effort. I'm willing to do it, but we also we're people power limited sometimes, and so if I could get someone up there, I'm not right now, given that all these chicks are dead that we put transmitters on. I'm not going to do that again right now until we figure it out a little better. But I think adults handle it pretty well, and I think it's been proven by all the people who have put transmitters on them that adults can handle it, at least up to a point in time. Then you never know what happens after that, after the transmitter dies and how long they keep them.
Okay, and so you've been referring to JF, that's JF Therian, and he also did one of our presentations, which should be on our YouTube channel also, so people can check that out too if they didn't.
If that was even him that asked the question, I know he's always like, say, we need to put more transmitters on the birds of Barrow. So
it was not. It was somebody else.
Okay, all right. Sorry, Dale, and sorry, whoever it was.
So somebody asked, and this is a great question, what are the best books, in your opinion, on snowy owls? The one that everyone's been trying to get me to write, which I haven't written yet. Well, the best book, I don't think there is a good book on snowy owls. I think, Potapov did his book a while back, and it had some interesting stuff in it. I think the better part of it was on the lemmings, but he provided a lot of information from Russia. But a book on snowy owls, I don't know if there's a book out there. Because every time there's a bunch of publishers that have been asking me to do it. God, I just don't have time. We probably have the best data set in the world,
And Arena's probably had a good data set. And I know the people on Violent Island are starting to get a pretty good data set over maybe 25 years now, but the owls aren't there every year. So it's big gaps in between. It's harder for them. We have to update the species account, and they're on my butt to do that. And I don't, I'm trying, but I don't think there's a good book on snowy owls. I don't know. I can't think of one. If someone else can, let me know. But I don't think that there's a ton of papers on snow owls, but you got to tease those apart now with some skepticism, and then kind of that's what we're trying to do in this thing on eruption migration is tease apart all this stuff. So, good book on snowy owls. I don't think it exists. There's some great photographic books on snowy owls, but I don't think that book exists yet.
Norm Smith asks, do you think bird flu has had an impact on them? In Massachusetts last year, we confirmed 7 banded birds died from bird flu.
Yeah, I don't know, Norm. I think we had one bird in Barrow this year that was brought in that was dead and had avian flu. I think they confirmed that up in Barrow. But it's not like we saw many birds dead in the tundra anywhere, whether they would last long. We cover the tundra pretty well. We find a lot of dead stuff. So this one did. I know all our great horned owls right here in Montana dying this year of avian flu for sure. One of our breeding females, she just died, broke my heart, But I don't know, Norman. Maybe we'll find out more next year. But I'm pretty sure that the vets at Department of Wildlife up there in Barrow confirmed avian flu in the snow owl this year.
So speaking of dead stuff, and you had mentioned the chicks had died with the young owls that had transmitters put on them died. What did they die from?
I don't know. And, Jeff is probably the best person to talk to on that. I just, know it through conversation, but I'm not so sure I know it through, if they retrieve carcasses and all that. We had one bird that flew into the water and drowned. I mean, that's on me. Terrible.
Is there an ideal temperature range for lemmings and snowy owls?
Yeah, sunny, 60 or 70 degrees, beach atmosphere. Temperature range, I don't know. You mean you're in relation to climate change? Is that the question? Or
I think they may just be asking what average temperature is it where they are?
Oh, it's terrible up there. It's so cold. I mean, it's warming, but I mean, it's just flat out cold, and I was up there last June. Our season's long. It's almost 4 months. But in June, I was going out. Wind chills were 22, 23 in June, every day for a while there. Every morning you wake up, it's about 35 if the wind's blowing, which it almost always is. It's pretty damn cold out there. But every once in a while the sun comes out and feels good. But on a 40-degree day, the chicks are gula fluttering, so they're overheating on a 40-degree day up there. It's pretty interesting to see that, And when you handle the snowy owls without gloves, you can feel that mesotyle, that thermal down there. It just warms your hands up. I'd love to have mittens made out of young snowy owl down, So, but anyway, yeah, it's miserable up there. Perfect for the snowies. Another reason you go back to the airport, and even here in Montana, when they show up, they're always in the coldest, nastiest, windiest places. They just seem to be able to do it. Some of the laboratory studies indicate that they don't really employ any kind of shivering until, minus 40, 50 below zero before they seem to be stressed out. And then they shut down a little bit. That's laboratory stuff too.
Does the pair usually return to the same nest site? Or, and do males and females mate together year after year? Or is that different too?
Yeah, those are good questions. They're harder questions to answer for us because we're not able to recapture the birds. We've got all the feathers. We have a whole bank of feathers, in the genetic analysis lab right now where we've been looking at that. We're able to get, female feathers, sometimes female blood. We get blood and feathers from all the chicks. Males, we have to rely on feathers. So we're trying to answer that. The same areas are occupied year after year after year. But my guess is it's probably not the same individuals, although we do see banded birds there. If you look at something, if I look at long-eared owls, we've got several thousand birds marked in our study. Never have we seen a pair remate in an ensuing year that was banded. Never, even though the same nest, the same tree, maybe the same male comes back every year. He comes back with a different female, or females come back every year, different male. We've never, ever seen that. And I suspect short-eareds and snowies are quite similar. Short-eareds we have a little bit of data on, and we never see them again. And snowies, we just need to recapture more of them, but we need to finish the blood work, in order to do that. And they were halfway through it before, and then something happened, and right now it's in limbo. So I can't tell you that, but I can tell you the same territories. We can go out there and find like 50 males this year, and they're on the exact same. Every year there's going to be a male on those territories. Now, it might vary from 20 males in the study area to 50 males in the study area. The same territories are occupied. And we have seen, again, we're left leg banded, and most people are right leg. So making an assumption that it's barrow, we're left leg banded. We see males and females with the band on their left leg. Sure, we do believe some of them come back. I would think it's highly unlikely that they mate with the same individuals again. But data needs to be analyzed.
And along with that, have you been able to discover where another nesting area might be if the owls aren't yet nesting at Utkivik, or are they just skipping nesting for the year?
Yeah, a couple of years ago, it was pretty interesting that we didn't have any bird. We had a couple birds. I think it was four nests at Ukiagvik or Barrow. But one of the waterfowl surveyors called me up, and he said it was, 100 miles east of us or somewhere. And they were doing the waterfowl surveys, and he said they found, 50 nests. So, and that happens. So you don't always get the information. So the birds might show up somewhere else and nest. And so, lemmings must have been high to have that many nests there. We weren't able to get on it because it was oil reserves. We had the permitting process was just a pain in the ass, and we weren't able to do it. But we also have birds that don't breed at Barrow, both males and females, So males will show up. I used to think that males, maybe we had a sex ratio difference, but our data on looking at sex ratios for the nest indicates about 50-50. So maybe females are more choosy, and they're the sex that moves and makes decisions whether to stay or go. But we do see like a pair will sit on territory for a month. And we go, all right, did they nest and fail? Sometimes we go there, we can find a nest that there's a scrape. We find female feathers there. Did she lay or not lay? Were the eggs preyed upon? Did she abandon? And other times we'll have a male and a female on territory for a month or more, and we can't find any indication that they even dug a nest out. So there's all these complications to it. What I think that goes on there. And we're trying to figure this out. So this year I'm going up. We're trying to figure out the lemming situation in April and May, and the owl situation April and May. Do these snowy owls just wander and somehow assess things very, very quickly? There's some data to indicate they track the melting snow. Well, when they show up at Barrow, there's no melting snow. So how do they assess it? Or do the males get there first? Why else would you evolve courtship displays and courtship flights and courtship if the females weren't assessing the males? So maybe the males are on territory. The males have done all the work, looking around, trying to find the lemmings. The females come and they assess males and what males can provide them. That's what I think is happening at Barrow. And we're trying to figure that out right now. So last year I went up in late winter, early spring, and that's going to be what I'm trying to do in the future here. How do they figure out the lemmings? If they can't see UV, and lemmings aren't coming above the ground, and can't see UV, then maybe that whole idea about urine reflecting the UV range with kestrels and all that stuff there doesn't hold true for owls. How else are they evaluating it? Maybe lemmings are coming up and being exposed more than we think, but we got to get up there in the wintertime. And so we can't just rely on making inferences from satellites to come to these conclusions. We need to make observations.
Do the cached lemming supplies ever attract carrion eaters to the nests?
Yeah. I imagine that they do attract them, but the owls are big and they're powerful. So any foxes that, I mean, I've seen them just whack the heck out of the foxes that come in within several hundred meters of their nest. Um, we don't, we have polar bears there, but not they don't really get inland that much. Usually along the coast most of the time. So nests along the coast might attract a sniffing polar bear. Who knows? But for the most part, I don't know how with red foxes supposedly are increasing. We've seen them, but we've always seen them. Um, I don't know. Do weasels come up to the nest and snatch one from time to time and just steal it? Do gulls? I think glaucous gulls to me are the biggest issue for snowy owls. But outside of that, they beat up on everything. But like a snowy owl, when I talk about these gulls, when the snowy owl is defending nests against us, the hominid researchers that we are, and we come to a nest and the female flushes, as soon as those glaucous gulls get up and move in, that male will abandon attacking us and turn right on the gulls and attack the gulls. I think they're the worst. Now, females occasionally kill the gulls. We've seen that. But I think that the glaucous gulls are a bigger threat than the Jaegers and maybe even the foxes at a snowy owl nest. And so with the increasing amount of, researchers up on the tundra, it's overwhelming now. They disturb the owls constantly, and then gulls will come in and eat the eggs, and they keep the females off the nest. They don't even know it sometimes. The students, they don't know it or they don't care, and everyone's doing their own projects, so they'll get near in areas where the owls choose the nest before anybody else. So if you're doing shorebird research, duck research, that all comes later. So the owls are there, and then everyone's doing that research tends to kick the owls off the nest and expose them to potential threats, and glaucous gulls are the biggest threat in my mind.
David Johnson would like to know, do you know any culture where snowy owls are viewed as spirit helpers, or where owls are protected by default because of cultural values?
For the snowy owls, no. I think that just in my years at Barrow or Reykjavik, there's always been an admiration for the snowy owl as a cool bird, as a pet, and as something that they carved that wasn't necessarily a big subsistence animal. But outside of that, there's a mask. I talked to a Nupia guy last winter when I was up there, and he talked about a couple snowy owl masks, But outside of that, nothing big with the snowy owls in Barrow anyway, or Reykjavik. I can't hear you, Carla.
Is it the youngest owls that migrate the farthest, as opposed to adults when they're leaving the tundra, or if they're leaving the tundra?
Yeah, I think that's where we often forget in this whole thing to describe these eruption migrations that snowy owls are migratory. Just like almost every species of bird up there moves somewhere once the snows come and the tundra freezes. Ptarmigan might be a little different local movements to windswept areas. Clearly when we see the eruption migrations, it tends to be young birds. But there's also numerous cases, and again, I defer to the trappers and banders, where they see not only young of the year, but 2-year-olds, they see adult males show up, adult females show up in territories. So I don't know if we're able to really tease that all apart yet, but I think the thing to remember is they're migratory. And whether it's a big female who's capable of withstanding the Arctic cold and capable of killing, waterfowl and seabirds and polynias or leads or along coastal areas that have snow, it's still a form of movement and migration. So I think, there's a lot to do, and we can't base, I know we want to sometimes base a, whole theory or a tenet based on a sample size of 10 or 20 or 30, but we can't do that, So we're still learning that stuff there, and I don't know if we can answer the question yet, but one of the things that is often left out of the equation is that snowy owls migrate.
Do the snowy owls need to see the lemmings to hunt, or do they use their hearing like other owls?
Not so sure I can answer that question. I'm sure they have keen hearing, but at the same time, I think they're a vision hunter primarily. If you look at the structural adaptations on the feathers, okay? So take a great horned owl, take a snowy, similar size, both buboes. If you look at structural adaptations, so take the feathers. If you look at the feather barbs and you look at the barbules on the surface of the feather and the trailing edge fringe, and you compare that with like a great horned owl is kind of a hearing hunter, but vision's important. You'll see that snowy owls don't have those structural adaptations. We look at all these species of owls; they don't have the structural adaptations for silent flight like something like a great horn does. And we can look at saw-whet owls and pygmy owls, for example. Same thing going on. And we can look at facial disc, the development of the facial disc. We can look at ear symmetry. And when we look at these things, we make comparisons at similar sized owls. We see that some of them that don't have the adaptations for hearing tend to be more vision hunters, perch, they see it and they go after it, which is those that have the structural adaptations tend to be more hearing hunters. But I think there's overlap on either side of that. I think they're vision hunters.
This person has noticed that small groups of snowy owls winter in the same very specific areas, like 1 square mile near them, each winter for the past several years. Could those be the same individual birds returning every year?
Yeah, that's pretty cool. If they all look like hatchia birds, then probably not. So I think there's two things that go on there. One is that I think they're programmed for certain, specific habitats when they migrate, and they tend to find those habitats that are most suitable for them, and they go there. The other thing, too, is based on banding anyway, and I think some of the satellite data also helps, but the snowy owl banders, that those guys that do this for, it's their hobby, but they're professionals. They can tell you, yeah, this bird showed up, 5 years in a row. This year he was here for 2 years, and 2 years later I caught he or she 10 miles away, but the same general vicinity. So we see a little bit of both of that. One is that they're programmed for specific habitats, and two is some individuals do return to these areas. And I think a couple of the Canadian researchers that had transmitters on them kind of show that. And we, if you look at ours, and they also show memory. I think it's really important here is that you can see where birds have used similar migration routes over the course of a couple seasons here, indicating that particularly adults, they may know where they're going versus young of the year, which may not.
Roar says they most possibly rely on vision since it's usually very windy on the tundra.
Thank you, Roar. I know that.
And then how long do snowy owls tend to live, and how long do they tend to keep reproducing?
In the wild, I'm not sure. I know Kay McKeever had a female snowy. I think that she was in her 30s, still laying eggs in captivity when West Nile got her, I believe. And you might ask someone like that who has them in captivity. I know Norman Smith and maybe a few other hardy plets, I think, too, have caught birds in their 20s after banning them as either hatchier birds or after hatchier birds. So that's one of the interesting questions that we're trying to figure up there. Only white, bright white, almost all pure white snowy owls breed. If they take 3 or 4 more years to become bright white, so they forego that, a breed until then they all look kind of the same. So when does senescence set in for either one of them? So just because, does that bright white male out there who's got 5, chicks in the nest breeding with this female, is he 5 years old or is he 15 or 10? So we don't know that. And I don't even think the molt data can get us that far. It can get us to a certain point. So hard to know. And the only way we're going to do that is mark recapture.
What is the territorial range for snowy owls, and can you speak about fighting amongst the males?
Okay, I don't know the territorial range. We just do the estimates of, on the nesting season and, how far apart nests tend to be. I would say in our study area, just a general observation, that it's, within a mile of the nest. As far as what it is in the wintertime, you'd have to ask some of the people that do the tracking. They probably have a better estimate of that. And then what was the other question? Fighting, right? Most of that is settled before we get there. We occasionally see where a male will kind of like get on the edge or come into a territory. And we see both the resident male and the female chase off intruding males. but we don't see it very often. Most of it settles. So I can't tell you. That's what we're trying to. When I go up there this year, and we're going to try to figure all that stuff out. What exactly is going on? And I've never done that before. Gone up there and at the onset of courtship, and see what happens.
Roar wants to know, have you analyzed molt feathers collected at nest sites to check identity of individuals by DNA as a substitute for banding and catching adults, since that's more non-invasive?
Yeah, well, we're sending those feathers down to the geneticists, and they say they can extract DNA and help figure it out. So that's in their court here. And what we're trying to find out if there's multiple paternities in some of the nests too. So they have it all, but it's kind of stalled out right now. But we've got huge samples. We just have to kind of get them to finish it up is what we're trying to do. I prefer, I'm more comfortable with marked birds that have bands on them, to be honest with you.
So I'm going to throw out, because I do vocal work. Have you ever looked at vocal individuality of individual birds? I mean, have you been able to tell certain individuals by voice?
Yeah, we've never recorded, but absolutely. Matter of fact, I can tell you one nest. If you saw the photograph of the nest and the gas pumping station in the background, every year we go out there and we hear, this really distinct hooter. He's back. Now, we've never caught him, but he's back. That's what we'd say. And then we went out there this past year and he wasn't around. So I think there is that for sure. I think there is that for sure. And so it would just take someone going up there and recording it all. But I think there are individual signatures. And every once in a while, we can recognize something that's distinct. I don't know if we can do it all the time, but every once in a while, this one male, he had this really distinct, and then he had this chuckle. But it was all in the same area. So was it him? Don't know.
Where do the adult males spend the winter?
There's probably better people to ask. I mean, I don't think we really know all that yet. I mean, clearly we see some down in, southern Canada and the northern tier state of the United States. We see that. I think it does appear that the preponderance of young birds maybe are kind of malish looking. But, I don't know if it's some of the Russian researchers. They've had a couple males that they've put transmitters on, and I think some of them have stayed up north or in the coastal areas. And you just got to wonder, do more adult males stay up north? I don't know the answer. And that's where the satellite stuff, I think, is really beneficial, would really help us out. And that's, do they get to the breeding grounds first? I mean, that's one of my questions, I think in most all species that I know about, it's the males who are courting the females, And so is it the males that get there, and the females are the more mobile sex and they move around? They see a male, if he's good enough, got a good territory, an adult, got money, boom, I'm here.
Have you ever had any polygamous males?
Socially. Okay, so we've got about 10 cases of that, where what we would say we have social polygyny, where the same male is tending two nests. We have some pretty convincing data of that. And so you go to, the way we figured it out, actually, the first time it happened, we had a male and he had a blood spot on one of his wings. I don't know what it occurred from, but it was a red spot on one of his wings. And we said, oh, interesting. And then we went to the next nest, whatever it was, 1,500 meters away, 2,000 meters away, doing that. And this male with a red spot showed up. Well, it's kind of interesting. So long story short, we decided we were going to figure this out. We go to this nest and then we'd walk to that nest and watch him follow us. And then he was feeding the two females. So we've got, I think 10 nests where we've had what we would call social polygyny, the same male defending and feeding two different females at the nest.
But are you saying that the one female had another male, or he was?
No, it was one male to two females.
So all
Isn't
those
that
eggs,
what you asked?
Yeah, but
Okay.
all the eggs were his at both nests.
Well, we don't know that genetically. We don't know that, but he was the male that was feeding both females and defending both nests. So that's when I say it was social. but we don't know if it was genetic or not, And so, and that was like in the early days, and we just weren't as keen to it. We were really excited. But I got to tell you this, I wrote it up and I went to publish it, and so like there was 4 referees or something. 3 of them said, "Oh, this is cool. This is pretty convincing." One referee went through this, this diatribe of, "You can't tell me, that you could tell that." I go, as you were slogging across the time, I go, "Wait a minute, the thing is hitting us at each nest. It's the same owl. It had a red spot." He just went through. I don't believe you. You're, that. Welcome to academia. Anyway.
What are the rates of juvenile mortality known for the first few years of life?
I can't tell you that. Once they leave the nest, and fledge, I don't know. We just don't know. It'd be nice to capture a bird in ensuing years. Yeah, we just don't know. We did have a young bird that Arena over in Wrangell Island, Russia. She marked in her nest in its first year of life. It dispersed and showed up in our area, but then it got hurt somehow and all that. So that was neat. But I can't tell you from our birds. And that's the whole thing. We talked about reproductive success. Well, that's not reproductive success. Reproductive success is when your chicks have their own chicks. We're just talking about fecundity here, how many young leave the nest. And so it's a little misleading to say, what is the reproductive success? How they just that. You got to have, the information on those in ensuing years, which we don't have in their survival. And you can do I think some people have done survival estimates. That's great when you're dealing with small data sets. Maybe you can do something like that, but you need big data sets. We just need bigger data sets.
Okay, we're going to wrap up with my favorite question, and I was going to ask this, and I forgot.
That's biased.
Yeah, I'm totally biased. I am going to totally exploit that. So this was asked by Martin Gerard, who's the great horned owl bander that I go visit in Saskatoon and Saskatchewan. So he taught me about great horned owls doing broken wing displays, which I thought they didn't do. And I do vocalizations, and great horned owls do a high whistling squeal when they do the broken wing display. And Martin is asking if snowy owls also vocalize accompanying their broken wing displays.
I don't know if it's simultaneous. I mean, clearly females scream at us and then do broken wings, but I guess I'm not sure, or maybe I've never noticed if as she's doing the broken wing, blurs away, if she's screaming. I don't know. Maybe I just have never noticed that. You would think that I would have, because they do scream at us, and then they do the broken wing and kind of go away. What I probably would have noticed if, they'll scream when they're in the air, they'll hoot when they're in the air, but when they come in and scream, then they turn and they do the broken wing. I don't think I've noted it. But it's something for me to keep in mind now.
There's your homework now, is you have to find out if they do that.
We have so much data. It's good. And, we have the same, our long-eared owls, we have the same amount of, our long-eared owl probably have way more data than we do snowy owl stuff. Tremendous amount of data on long-ears.
So in great horned owls, just for reference, in great horned owls, the broken wing display squeal sounds virtually identical to the male copulation squeal. And both the male and the female will do it in great horned owls.
Yeah. Oh, get your recorder and go up to the Arctic, and we'll put some muck boots on you and send you out there in 25 degrees, and you can do the recording.
No, I thought it'd be easier for just you to do it since you're there anyway.
Hey, how about recording when we get hit in the back of the head or in the butt or the back when you hear
the swear words that come out of your mouth when you get hit?
Yeah, for someone who likes them so much, I do yell at them. But I actually yell at the people who don't warn me. When I'll tell you one quick story. So we're up there, and I don't know, we were doing something for who knows what, Geographic or something. And I walked off the nest, and I got hit really hard. And I can't remember if I went down or stumbled pretty good. And I turned to say something to the person who's supposed to watch my back. And she was back there 50 yards with the photographer who had asked her not to go with me because he needed a photo of me being hit. So anyway,
the things you do for work. Well, we've taken a little more than 2 hours of your time already with the public. So thank you very, 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 very much for this. You've got a whole bunch of thanks in the comments also. There's still a bunch of questions that we didn't get time to answer, but that was expected with this huge of a crowd. So thanks.
No one told me any of the Patriots game score. What's the score of the game? I don't have to race over there now. No, thank you so much, everybody. I can't see you, but I mean, I hope it's worthwhile to you. I've always wanted to, this is what we do. This is what we do, and this is why we do it, because it's cool, and it's not always just about data and graphs. It's about how cool the animals are we study, and that's why I want to show you some neat photos along with some data. Data is for journals. This is, educating the public and stuff like that. So thank you. Support our research, and I guess, can I leave now then, Carla?
Oh, I'll kick you out in just a second. But first, I wanted to thank again, besides you, the Carl and Verna Schmidt Foundation for helping to support this, and for everybody who signed up and made donations to help support this series also. And our next presentation is February 5th, and that's going to be Hannah Tutongi talking about her hawk owl tracking research. So if you're not on the Owl Center's e-newsletter list already and you're interested in following us, we have 2 e-newsletters you can sign up with. One is more researchy stuff, so research summaries and conference news, and the other one is more what's going on with the Owl Center. And then these virtual owl expert speaker series presentations get posted to both of those, and you can sign up for those on our website. Now I'll let you go, Denver. Thank you very much for skipping the game for us. Maybe I can. Joe got the score for you. Bills 35, Patriots 23.
Is it game over? Okay, how about Tom Brady and the Bucks? Okay. All right, bye.